All right, so now that we know about circuit diagrams a little bit and also Kirchhoff's rules, I'm just going to introduce you to the first type of circuit. We'll be looking at the series circuit, and I'll also show you in this video an example of how you take measurements of a series circuit using the simulation that your lab is all about. So with a series circuit, I've got a picture of one right here. The main idea is that there is a single loop uh, for the electrons to move around the circuit. Um, Again, a loop is just connecting one end of the battery to the other. You need to have resistors in that loop, or else the current becomes theoretically infinite, and that's going to kill your battery and also probably cause a fire. But again, the main point is you've got your electrons. They only have one pathway. Every electron's following the wires back to the battery. There's no place for them to go one way versus the other. So again, every electron will go through all three of these resistors or light bulbs. Remember, they're the same thing in this example picture. Now, that also means that in a series circuit, if you take one of these resistors or light bulbs out, you've created an open circuit, just like closing a switch, or I'm sorry, just like opening a switch, and that will kill the circuit. So a disadvantage to these series circuits is that if one of these light bulbs burns out, the other two are instantly going to go out because the current will disappear. Again, if you have any gap, the air is not conductive enough to carry electrons, so the current will stop in the case of an open circuit of any kind, whether it's a burned light bulb or you flip a switch in a series. So I wonder if you can think of any examples of a series circuit. You have a line of lights and one goes out and the rest go out. If you can think of one example, you've seen a series circuit. All right, but I also want to show you guys a kind of an example of using the simulation to take measurements of a series circuit. So let's say we've got an example in front of us. We want to build a circuit with a 120-volt battery, a voltage source, and then we're looping it through three resistors, one of 10 ohms, one of 20 ohms, and one of 30 ohms. All right, fine. I'll bring you to the simulation. This is the same website I have linked in your assignment, as well as the assignment outline. So it'll bring you here. Here, I'll move myself to the other side here. You get a blank blue screen, but on the left side here, we've got all of our circuit components: wires, batteries, light bulbs, resistors, switches. Going back to the example, we want a 120-volt battery and three resistors. I'm going to use light bulbs instead of resistors. Again, they behave the exact same way, but I like to see the light bulbs because they give us the visual indication of how, or a little bit of what's going on in the circuit because they glow brighter or dimmer. A resistor, you can't see that. So here's our battery. I'll grab a couple wires, start looping the circuit around. With the simulation, you can make the wire stretch as far or short as you want, but I'm going to make a couple of connections with these wires just so I've got room to squeeze more components where I want. The way you do that is just by clicking any one of these circles and you can cut it open. So now I have the option of putting something in here if I want. That's why I'm making several wire connections here. But all right, here's maybe a good place to put our first light bulb. Let me just spin it around so kind of faces out. You don't have to do that. It's just preference of mine to make all the light bulbs face outside the inner circle. Something else you need to keep in mind when you do the simulation yourself is that when you use these light bulbs, you have to be careful. You want to make sure the current goes through it. That means you're connecting one wire to the bottom of the bulb and another one to the side. I showed you in that earlier video that a light bulb, if you connect a wire just to the bottom of a light bulb on either end, that's not going to work. You're not going to get any current if you don't allow it to flow through the filament inside the light bulb. That's where the light comes from. All right, so I got my last light bulb in here. And everything's connected. And our circuit's going. You can see in the simulation, they like to show you the electrons flowing, but I don't think I have all the numbers right here. Let me go back to the example. We want that light bulb, or rather the battery, to be 120 volts. I'll just click it, pump it up to 120. This is what your wall outlets feed you. Those light bulbs are really burning now, but I need to make sure their resistances are accurate. We want 10, 20, and 30 ohms. I'm just going to make the one on the left here the 10, center 20, and the right one 30. Click. Already 10 ohms. This center one, they all default to 10, so I'll pump it up to 20. And here's 30. Okay, so we've got this circuit set up in front of us in the simulation. But now if we want to actually get all the measurements we can without using equations, we're going to use the tools to measure everything. Before I show you the tools, let me show you an easier way to keep track of all this information. You want to make a chart. You can do this on paper or digitally. I've already got one set up here. Just a big chart. Fill one column with a V for voltage, another column with I for current, another column with R for resistance. And going across the rows, I like to put all the resistors. So this series circuit has 3 resistors, so I'll give each one a row, resistor 1, 2, 3. And then I'll have a bottom row for total, or equivalent value for the whole circuit. So if I fill in this chart, I've got every measurement: voltage for all 3 resistors, current for all 3 resistors, resistance for all 3 resistors, which we already know. So let's fill that in now. Resistor 1, I was making 10 ohms. And then 20 and 30. Okay. And we know our battery is 120. That's where all the voltage of the circuit comes from, so I'll fill that in here too. All right, so I've got 4 pieces of information just to start. Let me go back to the simulation, and I'll just grab our tools over here to take these measurements. Let's start with voltage. The voltmeter, as you might expect, is the tool that measures that voltage. So I'll drag it over here. The way a voltmeter works is it needs to read, again, the voltage potential difference between 2 points. If we want to measure the voltage through resistor 1 or light bulb number 1, then we're going to take the needles of the voltmeter and put one on one end and one on the other end of the light bulb. So I'm reading a voltage of negative 20 volts. Now I can flip these needles around, which I will do. I'll put the black one over here and the red one here, and I'll get positive 20. We can just deal with the positive numbers. I just flipped it around in that first test there. But again, if I put both of those needles on the same end, well, there's 0 volts here. There's no potential difference anywhere in this pathway until I go through a light bulb. So I'm going 1 needle before, 1 needle after. Bulb number 1, 20 volts through it. Let me fill that in my chart. Okay, so we're just taking these measurements virtually through the simulation. You know, had we been in school, I'd have you guys do something like this with real life circuits, but this is the best we can do in our situation. But all right, let me take a voltage reading of light bulb number 2. Looks like this one's got 40 volts. I'll fill that in the chart. And light bulb number 3, just drag each to each. If you get the negative, if you flip them around, just keep the positive number. This one's the 60 volts. Okay. All right, so we've got all our voltages filled in by taking the measurements. We don't need the voltmeter anymore. We're going to need to read current next. The tool for current is the ammeter. Again, these things are named for what they measure. Now, an ammeter works a little bit differently than a voltmeter. The ammeter has to go inside the circuit itself. You can see that. I mean, it's got the same red circles that the wires had. So in order to read the current going into bulb number 1, I'm going to stick this first ammeter right in here. That's why I left this gap. All right, so it looks like the current going into bulb number 1 is 2 amps. That's what I'm going to label over here under my current for resistor number 1. All right, and now I want to see what the current is going into bulb number 2. Throw another ammeter in a gap. Again, if you need to break a gap to make room for your ammeter, no problem. You just click the wire, split it open, and you give yourself some room. Notice how I split the wire and all the current stops, but I'll put it back in. 2 amps going into bulb number 2. I think you might start to see a pattern here, especially if you're thinking of the Kirchhoff rules. And if we split one more time, I'll split a wire right before bulb number 3, and I'll just throw another wire in there to make it easier. Current going into bulb number 3 is also 2 amps. Oh, look at me, I'm saying, should have said amps if I said volts before, my mistake there. All right, so we've got all the currents labeled, 2 amps everywhere. Well, sure, this is a series circuit. Every electron will go through every part of the circuit. Electrons carry charge. Current is the measurement of charge over time. So we'll read 2 volts, or sorry, 2 amps everywhere in this circuit. Even if I measure it going right into the battery or coming out of the battery, 2 amps every part of the circuit. So that's going to also be the total current. That is the current coming out or going into the battery. I can label that here. All right, so we've got everything filled in except for the total resistance. Well, something else we need to keep in mind is that we already studied Ohm's law. Every component of this circuit needs to follow Ohm's law. Remember, Ohm's law is V equals I times R. Or you can think about in terms of current. In that case, you're doing I equals V over R. Or if you want to think of it in terms of resistance, that means resistance of any one place in the circuit must equal the voltage divided by the current. Okay, fine. I like the first version. Multiplication just is easier for me than division. But if we take a look at every row, sure, every row is following Ohm's law. 2 times 10 is 20, 2 times 20 is 40, 2 times 30 is 60. First equation works. That means this bottom equation for the total value should also work. 120 equals 2. Well, that's got to be 60 ohms. And if you think about the Kirchhoff's rules, the loop rule says that in a loop, all of the voltages you burn going through resistors or light bulbs should equal the voltage you start out with in the battery. 20, 40, 60. That makes 120. The junction rule from Kirchhoff's rules says that if you have a junction, current will split. Some will go one way, some will go another. Well, in a series circuits, there's no splitting. We see that the currents equal everywhere. And that's exactly what we see in our chart. Hopefully this simulation, rather this video showing me the simulation helped you understand how it works. If you like, you can turn the simulation to schematics just to see the schematic representation of everything. But you don't need to do that. You can keep it as normal, realistic version. I already gave you guys charts for the for your simulation assignment. I would want you guys to build 4 circuits, circuit A, B, C, D, and just do the same measurements the way I did with the voltmeter and the ammeter to fill everything in. There are a few questions to answer when you're done, observation-based questions. But I do hope that this video helped you understand how the simulation works and how to take those measurements. And just, again, you can take all the measurements with the tools, but if you want to check everything, just go ahead and use Ohm's law across the way, across every row, that is. V equals IR in every case. That's the way it should work out. That should be it for this week. Once you complete this simulation assignment, you can fill in some more term maps if you still have a few terms to fill in. We are still continuing our circuits topic next week. I do hope you enjoy the holidays, and I'll see you again on Monday. Bye-bye.